Okay, so in the last video, we looked at the empirical rule and saw what it entailed, and then we left with a cliffhanger. And so what happens if our distribution is not symmetric and bell-shaped? Because then I can't use the empirical rule. Well, enter Chebyshev's theorem. To me, it's the funnest theorem to say. Chebyshev's. This theorem tells us that the portion of any data set lying within K standard deviations, where K is greater than 1, of the mean is at least, and then I've got a formula here I have to put in. It is 1 minus 1 over K squared times 100%. Okay, so what does that exactly mean? Well, let's look at a couple of cases. Let's suppose for a moment that K equals 2. What does this theorem mean? It means that if I do this calculation and say 1 minus 1 over 2 squared times 100%, let's see, that'll give me 1 minus a fourth, that's 3/4, or 0.75 times 100. That means 75% would be our value. So I can interpret that to say at least 75% of the data is within 2 standard deviations of the mean. That's what that means. Now, I can do it again, just so we really get a feel for what's going on. Let's say K was equal to 3. Same formula. I could do 1 minus 1 over 3 squared times 100%. And that would get us roughly 88.9%. So then that would tell us that at least 88.9% of the data is within 3 standard deviations of the mean. So Chebyshev's is a theorem. It's not like the empirical rule where it's approximately right. No. Chebyshev's is a theorem. It will happen. So it gives us like the minimum, the bare minimum. So with any data set, whether it's bell-shaped, left-skewed, right-skewed, it doesn't matter the shape. At least 88.9% of the data will be within 3 standard deviations of the mean. That's what Chebyshev's theorem guarantees. So let's look at an example, like an actual example. Example number 4. My calculator's in the way. There we go. Let's try this again. Okay, after running a survey from all statistics class at LHS, we gathered 40 responses. The mean number of pets per household was 2 pets, and the standard deviation is 1 pet. Using Chebyshev's theorem, determine at least how many of the households have 0 to 4 pets. Now, if I think of a number line here, so if I draw me a number line, and here, and I don't know what this shape looks like. So I'm just drawing a number line. If I start at 0 and I just count, 1 pet, 2 pets, 3 pets, 4 pets, 5 pets, etc. Now, they tell me 2 is the mean, 1 is the standard deviation. So this is sigma. That's sigma. So each unit is 1 sigma. So 4 is equal to mu plus 2 sigma. 0 is equal to mu minus 2 sigma. Which means what they're really wanting is how many are within 2 standard deviations. Because it says 0 to 4. How many within 2 standard deviations? Well, how do I know whether to use empirical rule or Chebyshev? I mean, 95% is within 2. They tell us here to use Chebyshev's, so that part's not a mystery. But think of our pets. Can we have negative pets? No. So this is probably going to be skewed. It's not going to be bell-shaped and symmetric. It's going to be skewed because after 0, that's it. You don't have negative pets. But anyways, so I'm going to do my calculation. 1 minus 1 over 2 squared times 100%. So that's going to give us 75%. You're like, well, how did you know that? Well, we just did it. But then also 1 minus a fourth is 0.75 times 100%, that's 75%. But wait, we're not done. They don't say the percentage. They don't ask what percent. They say how many. So how many means I need a number of houses. Need a number, not a percent. Well, how many did we survey? We surveyed 40. So what I need is 75% of 40. Well, that's going to equal 30. 30 households. That looks like something that's not households. Households. There we go. So what Chebyshev's theorem says is that at least 30 households will have 0 to 4 pets. It could be more, but it won't be less. At least 30 will have between 0 and 4 pets. Okay, so this video is kind of short. It's Chebyshev's theorem. In the next video, we're going to look at grouped data. So far, we haven't done group data. We've just done normal, here's the whole data set, and go. Now we're going to look at what happens when we have grouped data. So stay tuned for that one.